Hello, everybody. This is going to be a video that covers Tuesday the 25th, as well as Wednesday or Thursday the 26th and 7th. So on our do now for Tuesday the 25th, this is the do now. If the track below is frictionless, at what point will the cart experience unbalanced forces? So I want you to take a look at this, think about it, and as I read the next one, I'll come back to it. The total mass of the skydiver is 95 kilograms. Based on the information in the diagram, what is the acceleration of the skydiver? Include number and direction. All right, so let's go back to 1. Okay, now, a lot of you looked at this. I heard a lot of X's and a lot of Z's, but here at X, it will experience the unbalanced force. Up here, we still have some pretty big forces in play, and up here, same thing. So that leaves us with X. On number 2, I'm going to insert a text box over here so you can see this. Okay, so the total mass of the skydiver, so I have mass and I have force. So I'm looking for acceleration is equal to force divided by mass. Okay, oops, got to change that right over here. Sorry. All right, oop. All right. So our force, well, the first thing we have to do is we have to sit here and say, wait a minute, what's my force? So force, I have to take 600 and subtract 350 newtons. That leaves me with 250 newtons. So now I can plug that in because I have my F equals 250 newtons. My mass is equal to 95 kilograms. So now I can come up with acceleration is equal to, I need that to not pick up like that, equals to F times or divided by M. So it's going to look like this. 250 divided by 95. And you need to do the math on your calculator. And then your unit would be meters per second. Oh, second. Shift 2. There we go. So you'll have your number, and that's my unit. So you'll need to put the number and the unit. So you'll need to put both of these in Schoology. Now, for Wednesday or Thursday, depending on whether or not you had which block day you had, here's the mass of 4 vehicles and the net force is on the chart. So I already have force and mass. Which vehicle has the greatest acceleration as it enters the highway? So you're going to have to take each one of these, force divided by mass. So add another text box in here, and we'll say 4,500 divided by 1,500. That's equal to 3. The next one is 4,500 divided by 1,200, and that's equal to 3, but there's going to be a remainder. Then I'm going to have 4,500 divided by 1,800. That's going to give me 2 and a remainder. And then 4,500 divided by 2,000, that's also going to be 2 with a remainder. So the largest number, I don't even have to do the big math for this, sit here and figure it out on the calculator. I can simply say, hey, look, I was looking at multiples, and 3 with a remainder, which means I would have more numbers I could add. So my largest or greatest acceleration is going to be my little friend here, the coupe. And you would just put 1 with the word coupe. They want the vehicle, not this. So on this one over here, I'm going to turn that off. Oop, we didn't need that. We need to kind of pull out. Oop. So on the next one we have here, I'm going to exit my drawing, is which of the following describes the velocity? Well, what did we say velocity is? We said velocity is speed plus direction. Very good. So if I'm going in a circle, yes, I am changing. I'm changing direction. And I have right here 5 meters per second squared. 5 meters per second. I have speed. So knowing that the velocity, because it's a circle, is always changing, the direction is changing. So hopefully you can pick the right answer right there. Now, in class, we were working on a Hot Wheels project, but you are not here. So this is what you're going to do. And if you weren't here, this will actually be assigned to you directly. Here is Newton's law demonstration. You're going to first pick a law to base your project on. Then you're going to demonstrate the law by testing it on an everyday object, a boy, a ball, a toy car, skateboard, etc. On the next slide, you're going to insert an illustration of the text, so a picture, a drawing, or a video. Then lastly, you're going to do a write-up. Explain how your demo shows Newton's 3 laws. You're going to say how your demo showed which one of the 3 laws. Example, why the objects and the motion activity did what it did. You must include 3 vocabulary words in your write-up. So you want 100, here's your checklist for the slide. So this one, correct title, drawing or picture or video, explanation of the forces at work throughout the demo. Can be you voicing this over, that goes right here, or typed in. On slide 3, you're going to insert your write-up. Don't forget to include at least 3 vocabulary words. You're going to say Newton's whatever law says this, and my video shows this because, okay? And here's the ways you can answer. How does it display this? Explain in 2 or more sentences the motion that occurred using at least 3 vocab words. So if you are not in my room or in with Ms. Drew in class taking care of this lab today or on Wednesday, this is what you need to do, and it will be individually assigned to you. All right, well, you guys have a great evening, and we'll see you all tomorrow.